Welcome to True Projects. In this video, we will be explaining about pneumonia and COVID-19 detection using machine and deep learning algorithms. Introduction. It became clear that humans must learn to live with and adapt to COVID-19, especially since the vaccinations are created, they do not prevent the infection, but they just lower the intensity of the symptoms. Manual classification and diagnosis of COVID-19 and pneumonia is time-consuming and expensive. It requires skilled person. Automatic diagnosis, on other hand, would allow for real-time diagnosis without the need of human intervention, resulting in reduced cost. As a result, in this project, we will use X-ray images to test machine learning and deep learning approaches for automatic categorization and diagnosis of COVID-19 pneumonia. Objective. The goal of the project is to develop an efficient and automated COVID-19 pneumonia classification and diagnostic system using just X-ray images. The project intends to accurately detect and distinguish COVID-19 and pneumonia patients from normal ones by using combination of machine learning and deep learning techniques such as SVM, logistic regression, random forest, decision tree, KNN, naive Bayes, ANN, Inception V3 and ResNet 50. The system success will result in real-time and cost-effective and reliable diagnosis, offering vital support to healthcare experts and allowing for speedier responses in managing COVID-19 impact on humans. These are the requirements needed for execution. First one is hardware requirements, in that operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDE of 3.7 version is required. These are the algorithms used to execute the project. First one is support vector machine. SVM is used for binary classification to separate COVID-19 and pneumonia and the normal class in high dimensional feature space, leveraging maximum margin to achieve high accurate separation. Next one is logistic regression. It is employed to model the probability of COVID-19 or pneumonia presence based on chest X-ray features, making it suitable for binary classification task. Third one is random forest. Random forest combines multiple decision trees, enabling robust classification and handling complex data relationships to improve accuracy. Fourth one is decision tree. It partitions the data into hierarchical branches to classify cases based on X-ray features, providing an interpretable and easy to understand classification model. Fifth one is K nearest neighbor. KNN classifies cases based on similarity to neighbor the samples, making it effective for local feature patterns and suitable for multi-class classification. Sixth one is naive Bayes. Naive Bayes utilizes probabilistic models to classify cases based on chest X-ray features, assuming independence between features, making it efficient and effective with small data sets. Next one is artificial neural network, which is ANN. It is a deep learning model used to capture complex patterns and relationships in chest X-ray images, offering high accuracy for classification tasks. Eighth one is Inception V3. Inception V3 is a deep learning model specifically designed for image recognition tasks, effectively extracting hierarchical features from X-ray images. Ninth one is ResNet 50. It is a deep learning model with skip connections, addressing the vanishing gradient problem and allowing successful training of deep neural network for accurate X-ray image classification. These are the modules used for execution of the project. First one is upload chest X-ray dataset. Using this module, we will be uploading X-ray dataset to the application. Next one is pre-processed dataset. Using this module, we will apply some pre-processing techniques such as resizing and reshaping images, which can be accepted by all the algorithms. Pre-processed data will be split into train and test, where the applications use 80% of dataset for training and 20% of dataset for testing. Their test data prediction values can be used to calculate various metrics such as accuracy, precision, recall and F-score. Third one is run machine learning algorithms. Using this module, we will train 7 machine learning algorithms with above processed dataset. This following algorithms, which are SVM, logistic regression, random forest, decision tree, KNN, naive Bayes and ANN. Fourth one is run Inception V3 algorithm. Using this module, we will train Inception V3 with the above dataset and then perform prediction on test data and then calculate accuracy. Similarly, we will be performing ResNet 50 algorithm also. Sixth one is accuracy comparison graph. Using this module, we will plot all algorithm performance graph. Seventh one is predict disease from test image. Using this module, we will upload X-ray test image and then classify whether it will predict image contains COVID-19, pneumonia or normal. For execution of the project, first open the code folder. This is the code folder of the project, and this is the dataset folder which contains the data in it. This data will be used for predicting the models. And this is the model file which contains .h5 files, pickle files and numpy files which will store the algorithm information. These model file will be loaded into the project code during runtime to utilize the train models. And this is the test image. In this we will have the images which will be used for prediction of COVID-19, pneumonia or normal. And this is the main code file, and this is the Python code file. This will be used by the main code file during the runtime. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this we can interact with the program, and this is created by using Tkinter library in the Python. So first click on the button upload just XT dataset to open the dataset. Select the dataset folder and click on select folder. Here it is confirmed that dataset is loaded. Now click on the button preprocess dataset to preprocess the data. Here image is resized and reshaped. Close this image. Similarly, it will be preprocessed to all other images also. Here we found that there are 944 images. They are split into train and test. In train we have 755 images, in test we have 189 images. Now click on the button run machine learning algorithms. All the algorithms used in this project, first they will be trained on 755 images and then they will be predicting it on 189 images, which are train and test data. Now I will be clicking on the button machine learning algorithms. Here we have precision, recall, F-score and accuracy for SVM algorithm, logistic regression, naive Bayes, decision tree, random forest, KNN and artificial neural network. Now click on the button run Inception v3 algorithms. Here we can see Inception v3 precision, recall, F-score and accuracy scores. Now click on the button run ResNet 50 algorithm. Here we have ResNet 50 algorithms precision, recall, F-score and accuracy scores. Now click on the button accuracy comparison graph to perform all the algorithms. Here on x-axis we have all the algorithms and on the y-axis we have the scores. Here blue line, blue graph, it represents that accuracy, orange F-score, green precision, red recall. Among all the algorithms, ResNet 50 and Inception v3 is performing well. Now click on the button predict disease from test image. Here I will be selecting the image 1 and click on open. Here this image is predicted as COVID-19. Close this and I will be uploading the other image. This image is predicted as the person has pneumonia using X-ray image. I will select this image and click on open. Here this X-ray is predicted as normal, which means the person has no COVID-19 and no pneumonia. Close this GUI. Here in console we can see all the layers of Inception v3 and ResNet 50. Conclusion. Using chest X-ray pictures, project successfully created an automated method for COVID-19 and pneumonia classification. To accomplish accurate diagnosis, various machine learning and deep learning techniques such as SVM, logistic regression, random forest, decision tree, KNN, naive Bayes, ANN, Inception v3 and ResNet 50 are used. The preprocessing module of the system maintained data compatibility where performance metrics such as accuracy, precision, recall and F-score were computed for evaluation. High accuracy was established by Inception v3 and ResNet 50. The presence of COVID-19 or pneumonia was correctly diagnosed using real-time predictions on test photos. During COVID-19 pandemic, the research demonstrates the promise for cost-effective, rapid and dependable healthcare diagnostics.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.